Okay. So basically, this is our target for today. So I will continue explaining the previous question, and then we move to introduction of linear models, demonstrate of how to solve several questions in exercise 4D, which is basically number 1, 6, and 8. And then after that, if we still have time, you do focusing on solving number 7. So this is actually last time. Okay, last time what we have is that we come up with the equation that here we come up with the equation minus 0.09 t squared plus 0.0651 t plus 3.81, but equal to 1.5. Now 3.81 minus okay, so we have this. Now go with me. Last time I said to you, this is the equation, right? 2.31. But this is using Desmos. How about you use it with the TI Inspire CX? Okay, how? So what you should do is that you go to calculator here. You go to calculate. You go to calculate. Okay. And then after that, enter. And then you will find this. You will find this one, template. And then after that, what you should do is that you go to menu. This is menu. Here, menu. And then you have the algebra there, 3. Go to algebra. And then right click, you go to the right. And then you have numerical solve system of linear equation and polynomial tools. Go to polynomial tools. And click right again. And then you will find roots of polynomial, real roots of polynomial, and complex roots of polynomial. Choose the real roots. And click enter. And then you have polyroots bracket. Open bracket and close bracket. Now what you should do is that you input all these values. Minus here, this is minus. Okay, for the negative sign. Minus 0.09 x here, here x squared plus 0.0651 x plus 2.31. Okay, but the problem, don't directly click enter. Why? Because this is still undefined. So what you should do so that it actually will not cause error if you enter it. You press comma here, x. So that's actually how you define the variable that you're looking for. And then this is what you find in terms of equation. And then enter. Then you have the answer. Okay. You have a question regarding the methodology there? So that's how you find the roots. Okay, that's how you find the roots. Okay, but remember, the answers that you have, that's actually not the final answer. So for example, what you have with you is minus 4.717 and also 5.441. These are the roots. Okay, now I will write down the equation 0.09 x squared plus, or t squared in this case, plus 0.0651 t plus 2.31 is equal to 0. Remember, when you have the roots, you have these two values, right? The meaning of that, that's actually, if we actually do it in terms of roots, this will become t minus 4.717 and t plus 5.441. And then what we should do, Mr. Aldo? What you should do after this is that, remember, this equal to 0 and this equal to 0. So t is minus 4.717 is equal to 0. Therefore, your T1 is equal to positive 4.717. And then the other one is T plus 5.441 equal to 0. Therefore, your T2 is equal to minus 5.441. And as you know, in terms of timing, the time doesn't recognize the idea of minus. Therefore, the answer must be the positive one, or 4.717 years. Okay. Now, 4.717 years is basically January 2014 as our starting point based on the question here. You plus it with 4.717 years, which we can call it as around late 2018. Done. That's the answer for number 5D. Find the year in which the researchers predict the cost of solar energy will fall below $1.5 per watt. It is 4.7 years after, which is around late 2018. Okay. Explain why the function E now. Explain why the function may not lead to reasonable predictions for a year beyond 2019. Now, beyond 2019, basically, 2019 is 5 years after. So 1, 2, 3, 4, 5. Beyond, after 2019, or after 5. After t is equal to 5. So your answer, this will not be reasonable, because if we keep using this line, it is impossible for the price of the solar to be negative, right? How come you pay? Oh, well, what's the cost of your electricity? Oh, negative $5. What does it mean? It's impossible. That's not the case. So the way we say the reason is that the researchers, okay, or would be extrapolating far beyond the data set. Also, the values of the function become negative after 6 years. After 6 years, or basically when 2020. So that's how you put the reasoning for the 5E. Question? If you have question, please let me know. Clear, Agnes? Okay. Finn, okay? Good. Okay, now we move to linear models, okay? So that's actually, okay, this is the concept of linear models. So like the name stands for, linear model is actually explaining about linear function. What is the meaning of linear model? Basically, it represents a context with a constant rate of change, when the value of the gradient is always constant. So for example, when we say that the gradient is equal to 5, then the rate of change is constant as at 5. Okay. Okay, now I want you guys to start observing your textbook page, or in exercise 4D, which is actually in page. I want you to open to exercise 4D now. Okay. Now, state which of the following are linear functions. If the function is linear, state its gradient. Okay, so for example, fx is equal to 3. Now remember, fx is the range. Okay, so we can say that this is the line y is equal to 3. When line is equal to 3, is it a linear function or not? What do you think, guys? Is it a linear function or not? If it is not, why? If it is a linear function, why? What do you think, guys? Is the line of y equal to 3, is it a linear function or not? Give your opinion in the chat room. Okay. Thank you so much. Okay, if it is linear, then what's the value of the gradient? Okay, thank you. So true that okay, so the line y is equal to 3, or the equation y fx is equal to 3 is a linear function. With gradient or m okay. How do we know that this is m is equal to 0? Okay, this is the equation of line. Y is equal to mx plus c. And then as you can see, this is line is equal to y equal to 3. So as you can see, y is equal to blah, 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 x plus 3. Because there is no x, then we can know that m is equal to 0. Done. Okay. Now we go to B. Gx is equal to 5 minus 2x. This is a linear function, yeah. Why? Because the gradient is minus 2. Done. Okay, now we move to C. Hx is equal to 2 over x plus 3. Is it a linear function? No, this is like exponential function. Why? Because hx is equal to 2x power of minus 1 plus 3. Remember, the equation of line is y is equal to mx plus c. X has to be to the power of 1. While here, as you can see, it's not to the power of 1, but to the power of minus 1. So this is clearly not, where is it? Okay. Wait, where is it? Okay. So this is clearly not a linear function. Okay. Now we move to D. Tx 5x minus 2. So first of all, we need to expand this a little bit. 5x minus 10. Now the equation of line is mx plus c. Then we know that m is equal to 5 and c is equal to minus 10. Done. So this is linear. It is a linear function. Okay. Now, is there any question before I go further? If you have question, don't be shy. I will not reveal your name. Okay then, if there's no question. Now, I want you to start, just read the question for number 6. I want you to try to understand what the question is actually trying to say to you. And after that, I'll explain how to solve this. Please read by yourself what's actually number 6 is all about. Okay, guys, so this is actually the question. In January 2018, Sneakies was the largest shoe company in the industry. Their sales represented 64% of all shoe sales by all companies. However, analysts projected that in January 2019, they would sell only 62.65% of all shoes, and that without any changes, their percentage share of shoe sales would decline at the same steady rate for the foreseeable future. A. Find an equation in gradient intercept form for the function st that represents Sneaky's shoe sales as a percentage of all shoe sales t years after January 2018. Okay, so first of all, we need to write down the informations that we have. Okay, so the informations that we have, First is that at January 2018, Sneakies had 64% shoe sales. And then January 2019, which is 1 year after that, is about 62.65%. The easiest one to solve this question is that you need the help of graph. So I do simple graphing. So we have 0 here. 0 here represent January 2018. And then this is T years. And then this one is 1, 2, 3, 4, and so on and so forth. And then I said this one, let's say this is 60%, 64%. So 0,64. So this is the coordinate. The one that I put green, this is the coordinate of 0,64%. So 0 year. Now zero year in this case is basically telling us about the idea of January 2018. And then after that, this one is in terms of percentage. Percentage shoe sale. This is the y-axis. The x-axis is the years. And then we have 64%. Let's say here, around here, 62.5%. And then this one. And then I will do this. And then I will connect them with blue line. This is your equation of line. Now, if we know that, then we can say that the y-intercept C or y-intercept equal to 64%, or basically just namely 64. What is it the y-intercept? Y-intercept is basically the coordinate in which that it touches the y-axis. Here, basically, what's y value when x is equal to 0? That's actually the idea of y-intercept. Okay, the coordinate in which that it touches the y-axis. Okay, and then the equation of line is y is equal to mx plus c. We already know the value of the y-intercept. Our job is now to find what's actually the gradient. Now, gradient is equal to delta y over delta x. In this case, our delta y is about percentages. Okay? In this case, it's basically what? 62.5, which is the after, minus, okay, maybe too far. Maybe I should say y2 minus y1 over x2 minus x1. This is your x2, y2. This is your x1, y1. Now, as you can see, this is your x1, this is your y1. Here, x2, y2 is basically 1, 62.5 equal to 62.5 minus 64 over 1 minus 0. Yeah, 1 minus 0, of course, 1. 62.5 minus 64 is equal to 1.35 minus 1.35. Therefore, the gradient is equal to minus 1.35% over year. Or basically, the gradient is minus 1.35% per year. That's your gradient. Therefore, the complete equation is equal to y is equal to mx plus c. Now your y, based on the question, is talking about ST. So ST here, ST equal to the gradient here minus 1.35. Your X is no longer X, but is in T years. T plus the y-intercept. This is the equations that the question is like looking for. So this one refers to this one refers to this one refers to this. Okay, 4. Okay, Angel. So, again, there's a little mistake again. Sorry. So, here, sorry. It should be 62.65%. So, I'm wrong. So, here, it should be 62.65%. I'm the one who wrong. So, here, so this should be not 62.5, but 62.65. Sorry, my mistake. So that's why the answer must be minus 1.35, and then this is the answer. Yeah, thank you for the correction, Angel. Okay, so that's A. That's how you answer A. Now we move to B. Find the year when Sneakies is predicted to no longer sell the majority over 50% of the shoes. Now, the idea is that it's basically saying that what is it T when ST is equal to 50%? So that's actually the question. Now we know that ST is equal to minus 1.35 T plus 64. But now the ST is 50. So 50 is equal to minus 1.35 T plus 64. Then what we should do? This one move to the left, becoming positive. 1.35 T is equal to 64 minus 50. Then 1.35 T is equal to 14. Then T is equal to 14 over 1.35, which is equal to 10.37 years. Okay, so 10.37 years after January 2018, it will be during or around year of 2028. So in 2028, that Sneakies no longer sell the majority. 2028, or about 13.37 years after January 2018. Now we move to C. Now we have the graph now represent the projected sales of rival company Foodtalker. Show that Foodtalker is growing faster than Sneakies is declining. How do we know it's actually growing when there's an upward trajectory? There's upward direction. Okay, then you know the gradient is actually positive. And while the Sneakies, the gradient is negative, minus 1.35. This should be plus something, which is bigger than 1.35. Now, how do we know? Yeah, just using the formula. Now, your Y2 is 18, minus your Y1 is 13, over the scale of 2 years, 2 minus 0, which is equal to 5 over 2, positive 2.5. 2.5% per year. So this is the gradient of Foodtalker. And then the equation offline is y is equal to mx plus c. Now, your m is equal to 2.5. Yeah, basically this is the answer for C. Done. This is C. Now we move to D. Find an equation for ft, the function representing food talker cells over time. Okay, now I will talk about the equation offline. Now, y now is actually in terms of ft, the function. Here, ft equal mx. M is the gradient, 2.5. Your x is in time, t, plus c, the y-intercept. The y-intercept here is 13. So plus 13. Therefore, the equation should be 2.5t plus 13. Or you can say it as ft is equal to 13 plus 2.5t. Either way, they are correct. Okay, now the last one. Find the year when Food Talker will sell more than shoes, sneakers. ft is equal to st. So 13 plus 2.5t is equal to 64 minus 1.35t. So we have 2.5t plus 1.35t is equal to 64 minus 13. Basically, you will have t is equal to 13.24 years. So this is the time needed for Food Talker to